In this video, we will cover what is flip-flop, how many types do flip-flop have, what is asynchronous counter, and application of flip-flop regarding the asynchronous counter. So firstly, what is flip-flop? Flip-flop is a clocked synchronous bistable multivibrator that used to store information. The output changes only at a specific point, edge, of triggering input, which is clock. The two types of flip-flops are positive and negative edge triggered. We can differentiate this negative and positive edge triggered by looking at the clock. When we look at clock input, there is a circle, thus it indicates the negative edge triggered, while to recognize the positive edge triggered there is no bubble at the clock input. Flip-flop have several types that have different design which give different output. Human develop it to give better quality of output. For example, edge-triggered SR flip-flop, edge-triggered D flip-flop, edge-triggered JK flip-flop and edge-triggered T flip-flop. Let's take a look at them one by one. Firstly, we have edge-triggered SR flip-flop. In this circuit diagram, the output is changed, which is the stored data is changed, only when you give an active clock signal. In this circuit, when you set S as active, the output, Q, would be high and Q naught will be low. Based on truth table, if S equals 1, R equals 0, flip-flop is set on positive clock edge. It remains set, if already set. Secondly, we have edge-triggered D flip-flop. In this circuit diagram, the output can be only changed at the clock edge, and if the input changes at other times, the output will be unaffected. The change of state of the output is dependent on the rising edge of the clock. The output, Q, is same as the input and can only change at the rising edge of the clock. Thirdly is edge-triggered JK flip-flop. In this circuit diagram, it is quite similar to SR flip-flop. This circuit is versatile and more widely used. Besides, it is better than SR flip-flop as there is no invalid state. In simple words, if J and K data input are different, which are high and low, then the output Q takes the value of J at the next clock edge. If J and K are both low, then no change occurs. If J and K are both high at the clock edge, then the output will toggle from one state to the other. JK flip-flop can function as set or reset flip-flop. And lastly, we have edge-triggered T flip-flop. From the circuit diagram, it is a modified form of JK flip-flop by connecting both inputs J and K together. This flip-flop has only one input along with the clock input. These flip-flops are called T flip-flops because of their ability to complement its state like toggle, hence it is called toggle flip-flop. Let's move on to the next part. What is asynchronous counter? Asynchronous counters are those whose output is free from the clock signal. As the flip-flops in asynchronous counters are supplied with different clock signals, there may be delay in producing output. In counting sequence, the flip-flop in which external clock pulse is passed act as LSB. The flip-flops are used in toggle mode. Another name for asynchronous counters is ripple counters, because of the way the clock pulse ripples its way through the flip-flops. Asynchronous counter also have several types design. Firstly, 4-bit asynchronous up counter. This counter can count upward. Secondly, 4-bit asynchronous down counter, which count downward. It is also can be designed as a simultaneous 3-bit asynchronous up, down counter. Lastly, we have 4-bit asynchronous BCD counter that used in decade counter. Next we will discuss about the application regarding to asynchronous counter, which is binary ripple counter. A binary counter is a 2-mod counter which counts up to 2-bit state values. For example, 2 to the power of n is equals 2 to the power of 2 equals 4 values. The flip-flops having similar conditions for toggling like T and JK are used to construct the ripple counter. Beside is a circuit diagram of a binary ripple counter. In the circuit design of the binary ripple counter, 2 JK flip-flops are used. The high voltage signal is passed to the inputs of both flip-flops. This high voltage input maintains the flip-flops at a state 1. In JK flip-flops, the negative triggered clock pulse use. The outputs Q0 and Q1 are the LSB and MSB bits, respectively. The truth table of JK flip-flop helps us to understand the functioning of the counter. When the high voltage to the inputs of the flip-flops, the fourth condition is of the JK flip-flop occurs. The flip-flops will be at the state 1 when we apply high voltage to the input of the flip-flop. So, the states of the flip-flop's passes are toggled at the negative going end of the clock pulse. In simple words, the flip-flop toggle when the clock pulse transition takes place from 1 to 0. The state of the output Q not change when the negative clock edge passes to the flip-flop. Initially, all the flip-flops are set to 0. These flip-flop changes their states when the passed clock goes from 1 to 0. The JK flip-flop toggles when the inputs of the flip-flops are 1, and then the flip-flop changes its state from 0 to 1. For all the clock pulse, the process remains the same. The output of the first flip-flop passes to the second flip-flop as a clock pulse. From the above timing diagram, it is clear that the state of the second flip-flop is changed when the output Q0 goes transition from 1 to 0. The outputs Q0 and Q1 treat as LSB and MSB. The counter counts the values 00, 01, 10 and 11. After counting these values, the counter resets itself and starts counting again from 00, 01, 10, and 11. The count values until the clock pulses are passed to J0 K0 flip-flop. The easiest application of ripple counter can be seen in traffic light. For each light, they have specific varying time length to make the light stays. So, to have a well-functioning traffic light, it must be counted, for example count from 0 to 19, with a specific clock. It works same as the ripple counter that explained before. Here's some additional info for you before using the asynchronous counter. There are some advantages and disadvantages of asynchronous counter. For advantages, it can be easily designed by D flip-flop or T flip-flop. It can be used in low-speed circuits. It is used as divide by N counters. They are also used as truncated counters. To design any mod number counters, such as mod 4, mod 3. Next, for disadvantages, for resynchronization, extra flip-flop are needed. Additional feedback logic is needed to count the sequence of truncated counters. Keep in mind that mod is not equal to 2n. The propagation delay of asynchronous counters is very large, while counting large number of bits. Due to propagation delay, counting errors may occur for high clock frequencies. They are slower as compared to synchronous counters.